solving a problem that involves projectile motion. So projectile motion is just like anything that's shot up into the air. You could throw a ball up into the air, you could launch a ball up into the air, however you want. That's going to be projectile motion, okay? Now, for our purposes, we are going to neglect air resistance, because obviously if you're really getting into physics, like that's going to play a role in how fast the ball goes up or whatever, but we're not going to worry about that. So if air resistance is neglected, the height, which is always going to be called S, why the position function is always S, I have no idea, but it just has always been that way as long as I've been doing math, which is in many years beyond that. Probably has to do with Latin or Greek. So S is the position. It has to be in feet if you're using this particular formula, okay? If you wanted to measure in meters, this formula would not work. Has to be feet. Of an object propelled directly upward from an initial height, S initial feet, with initial velocity of V initial feet per second, is this formula here. So anytime you see these little sub-zero numbers in math or in physics, that's always representing an initial value. I do not have a physics background. I have a math background, and I've always learned that as V naught and S naught. So that is how you'll probably hear me say it just out of habit. You, like in physics or science, probably learned V initial, S initial. Same thing, you'll hear me use both the naught. It's not like N-O-T, like the word not. It's like the British zero, not. That, anyways. It doesn't matter. You'll hear me say both. Anyhow. So the formula is this. It is S of t is equal to negative 16t squared plus V initial t plus S initial, where t is the number of seconds after the object is projected. And then that negative 16 is a constant that comes from the force of gravity on the Earth. You may know, like in feet per second squared, gravity on Earth is negative 32 feet per second per second. Where does the negative 16 come from? Calculus. That's all you got to know. You can work your way back from the gravitational force is the acceleration. You can go backwards to velocity, and then you can go backwards to position, and that's where this negative 16 comes from. You don't have to know why. You just have to know that it's there. Additionally, you do not have to memorize this formula. If you need it, I will provide it. You just have to know how to use it. Okay? So, let's take a peek at this example here. Let's leave that formula up there. So a ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. First, we want to write the function that describes the height of the ball in terms of time t. Well, they've given us initial height, that's S naught, and then they've given us initial velocity, which is V naught. And so all we have to do is plug those in. You're going to have an equation that has t's in it, but all of these constants we're going to substitute for. So our function, S of t, is simply going to be negative 16t squared, that part never changes, plus V initial is 112, so that's 112t, plus S initial, which is 75. And there it is. There's your function. So now we can use that function to go ahead and answer some other questions. So the first question that we could ask is, after how many seconds does the projectile reach its max height? And what is the max height? Maria, you want to close that door for me, please? So, first question, this parabola that we would get from this equation here, thank you. Would this be a parabola that opens up or down? Down. How do we know? Right. The 16 is negative, so that means it opens down. So if we think about what this graph would look like, it's going to be something like this. It doesn't start at 0. It starts at 75. And as time goes on, the height of the ball is going to increase, and then it's going to decrease until it hits the ground. Where would I need to look on that parabola to figure out its maximum height? The vertex. That's exactly right. So we're trying to figure out this point. And the vertex, remember, is going to be HK. Well, when we look at that HK, H in this instance is going to represent the time in seconds, and K is going to represent the height at that time. So as long as we figure out the vertex, we will know how many seconds it takes, and we will know how high it goes. How do we find the vertex when we're looking at a quadratic in standard form? Negative b over 2a. That's what we did yesterday. So we can go from there. X equals negative b over 2a, same exact process that we did. We're just not going to graph it this time. So you get negative 112 over 2 times negative 16. And I've already done this work for you. It comes out to 3.5. So that's the h. And really, if I'm being really precise, x probably isn't the variable we should use, because what does this represent? It's t. So now, if we want to figure out the height, which is going to be the second half of the vertex, we want s of 3.5. And again, you just stick that in your calculator, which I have already done for you, and you get 271. So let's go back to the question. The first question, after how many seconds does it reach its maximum height? What would that answer be? Right, so after 3.5 seconds, the max height is what? 271 feet. Correct. Questions on that? So this example that we're looking at here is projectile motion specifically. It does not have to be, but the process would still be the same. Maybe I give you a function and I say, this function represents the revenue for 1 month for some company. What day of the month did they reach their maximum profit? You find the vertex and figure out the maximum that way. Just remember what we've talked about. If it asks where or when something happens, that's always talking about the x. And when it asks what it is, it's always talking about the y. What is the maximum height? What is the maximum profit? That's going to be your y value. When does it happen? Where does it occur? That's going to be your x value. Okay? All right, there's a couple of other questions on here. So this is an interesting one. We're looking at an inequality. For what interval of time is the height of the ball greater than 200 feet? Well, we'll use the exact same equation. Okay, so we have negative 16t squared plus 112t plus 75. And what we want is where this is greater than 200. So now if we're going to try to solve this equation, what would be the first thing we need to do to get it set up correctly? Yes, someone said, subtract 200. It's got to be compared to 0. And especially if we're going to use the quadratic formula, which is probably what we'll do here because these numbers aren't very nice, it's got to be equal to 0. So when we subtract 200 from both sides, we get minus 125 is greater than 0. Bless you. So now, I did not spend a whole lot of time trying to factor this. I looked to see if 16 maybe went into all three of those things, and it doesn't. And after that, I give up on the factoring just because these numbers are kind of gross. So instead, I just went straight to the quadratic formula here. Remember, the quadratic formula, that is something that I do expect you guys to know. So it's been a little while since we did quadratics. If you need to brush up on your quadratic formula, start singing the song or whatever you got to do to help you remember it. But so this will set up the opposite of b, so that makes it negative 112, plus or minus the square root of b squared, so that's 112 squared, minus 4 times a, which is negative 16, times b, which is negative 125, And then all of that is over 2a, so that's 2 times negative 16. I would not recommend putting this whole thing into your calculator at once, because 1, you're going to have to do it twice since there's a plus and a minus. And 2, like there's just too many places that you're going to need parentheses that you might make a mistake. So I always start by simplifying my radical. And underneath the radical, you get negative 112 plus or minus the square root of 4,544 over negative 32. That's what I will work with in my calculator, just because it kind of eliminates some room for error. But like if I said, how high is such and such happening, you're not going to give me an answer like, oh, well, it's negative 112 plus or minus the square root of this feet high. No, we want a decimal in this sort of a real world situation. So we have to put this in the calculator twice, once with a plus, once with a minus. If you're going to put this all in at once, don't forget that you have to put parentheses around the numerator and the denominator to make sure it does the correct order of operations that we want. And again, I've already done this for you, so I'm just going to go ahead and tell you what it is in the interest of time. So the two things we get are t is about 3.93 and 5.607. It didn't tell us what to round to. 3 is a pretty good standard if it doesn't tell you. Everyone always tries to do like sig figs. I know you do that in science. In math, how many digits do we want? As many as you can get. Sig figs is not a thing in math. We just want all the decimal places that you can manage. 3 is plenty for our purposes right here. Okay, so now we got to think back to when we did quadratic and polynomial inequalities. So we have, whoops, I'm rolling over my cord. These are the two solutions where it is equal to 0. But remember, we want to know where it's greater than 0. So the way that we did this before was we plotted those two boundary points on our number line and tested points in between. But because we know enough about the graph of a quadratic, we can kind of figure out what this is going to look like. We already know, because the 16 is negative, what do we know about this parabola? It's upside down, so it opens down. So we know that those x-intercepts, we're looking at a graph that is something like this, okay? So if we want where it's greater than 0, we want this section that is above the x-axis. So do we want the times that are in between what we got or outside of what we got? In between, yeah, because that's the part that's above the x-axis. So the answer would be 1.393 less than t less than, what do we get, 5.607. Okay. We use an inequality because it asked for an interval. I like using inequality notation here so I can show that this is t, we're measuring time. But you could also use interval notation and write it this way. That would be just as correct. I don't care. They both represent the same interval. Okay. Questions? You can always look at the graph. If it was an inequality where it was less than 0, then we'd want the parts that are below the x-axis. So then the last question is, after how many seconds will the ball hit the ground? What is that asking us to find? Where the height is 0. That's right. If it lands on the ground, the height of the ball is 0. So that's what we're trying to find. So we're going to solve a similar equation. Negative 16t squared plus 112t plus 75 equals 0. And again, I would use the quadratic formula. I'm not going to make you sit through that again. I'm going to say dot, 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 quadratic formula. And I'll just tell you what you get. You get two answers. Approximately negative 0.616 and positive 7.616. Do both of those answers make sense? No, the negative one does not make sense. So why are we getting a negative answer? Like if I throw the ball and it goes up and it comes down, why is my first time not 0? It didn't start on the ground. That's exactly right. Remember, our initial height was 75 feet. So again, our graph looks something like this. So we're getting this x-intercept over here. Even though this part of the graph doesn't matter, it would still have an x-intercept over there. It just doesn't apply to our situation here. So the answer would just be 7.616 seconds.